All right, today our notes are on writing and graphing linear functions using slope-intercept form. So you've seen slope-intercept form, but as a reminder, it is a way to write linear equations. It's not the only way. We'll talk about other ways coming up here soon, but it is kind of the most basic starting way. So for what we're doing here, it's a great tool. It's probably the best form for drawing a graph. So we have y equals mx plus b. Y and x represent all of the y and x values of points on the graph. M, we know, represents the slope, and b represents the y-intercept. Remember that y-intercept may also be called initial or starting value. Those are other terms for that thing. But either way, it's where our graph runs into the y-axis. And it's actually the most, the basic starting point for how we're going to make our graph. So here we have 3 steps to follow if we want to graph something that is in slope-intercept form. So we're given an equation, we want to put it onto a graph, we use these steps. First thing we do, we make a point at the y-intercept, and that's at 0, b. So the y-intercept in the equation shows up as a single value, but remember that it represents an ordered pair where x is 0 and y is whatever b is. So I want to do that on this graph here, but notice we'll probably fix this by the time we're working on this in class, but since it's not quite right here and part of it got cut off, it's a great chance for me to remind us about resources. So I need a coordinate grid because I don't have the one on that page. So I'm going to come over here and I'm going on a Chromebook screen. You would just long press, just hold down your finger and then it'll pop up and you hit copy. And I'm going to go back over here and just off to the side, since I'm using a keyboard, I have to hit Control V. You should be able to long press and do that too. So now I have this graph here that I just took from the other page or made a copy of from my other spot, and I can use it for this problem where I'm missing a graph. Not something you normally need to do in your notes because we'll fix that, but it's a nice thing to have there. So step 1 was to plot the y-intercept at 0, b. So I have 4 as my y-intercept here, so I'm going to make a point at 0, 4. So that's right here on my new graph. Step 2, so we did step 1. Step 2 is use the slope, so m, or slope, to get another point by following the rise and run. So in this case, I have -3 over 2 is my slope. And remember, on top, that's my rise, and on bottom, that's my run. So I'm going to, from the point that I'm currently at, which is 0, 4, I'm going to follow that rise and run pattern, always remembering that run is always to the right. Always, always. So my rise being -3, I'm going to count down 3 units. So 1, 2, 3 along my y-axis. Then I'm going to go 2 to the right because the run is always to the right. 1, 2 puts me right here at 2, 1 for my second point. So that's my next point. But what would I do if that went off the graph? So maybe I would go off the top or bottom of the graph. We can always reverse the rise and run as long as we reverse both of them. So instead of going down and right, I could find another point by going up and left. So here I could go 3 up and 2 left by reversing the direction. But you only generally need to do that if your line is going off the graph. The last step is to connect the points with a line. Always use a ruler when you do this. If you're working on a OneNote, you can use this ruler by toggling it on and off up here on the drawing toolbar. And you can set it to the right angle that goes through both of your points, and then use your pen tool to draw a line. Then you can toggle the ruler off and add the arrows at the ends of the line. So when we graph lines, there are always 3 characteristics they should have. So number 1, it goes all the way across the graph. All the way across. So that means if I'm drawing a graph, I'm not going to draw just like a little stubby line like that and leave it in the middle of the graph. That's going to be important, particularly when we get to systems of equations and we want to see lines intersecting, or systems of inequalities where we need the line to fully split the page into 2 different regions. So get used to drawing lines that go all the way across the graph. Number 2 is always use a ruler, or if you're drawing on paper, like on a quiz, you can use the edge of your ID or your ID holder. It makes a nice straight edge. But in OneNote, you have a ruler right here, so toggle it on, tilt it to the right angle, and use it to connect your 2 points. Number 3 is they have arrows, so always add arrows. The arrows represent that lines go on forever. They don't just end where you stop drawing it. You may have noticed that like in Desmos, when you draw a line, there's no arrows at the end, but that's because you can always zoom out and the line actually does go on forever because it's digital. So you can zoom out forever and the line always goes to the edge of the graph. So you may see sometimes that when we create graphs using a digital tool like Desmos, it may just run up to the edge of the graph and then kind of look like it keeps going by going off the edge. That implies that the line goes on forever, but for you drawing it by hand, always put arrowheads at the end to show that it goes on. All right, so we drew our first graph of a line. So we followed 3 steps. We plotted the y-intercept at 0b. We used the rise and run to find one more point starting from 0b, and then we connected the points with a line that is straight, goes all the way across the graph, and has arrows. All right, next, what if your equation isn't in slope-intercept form? Well, we'll talk about other like actual forms later that you can use to graph from, but for right now, we want to figure out how to change a line into slope-intercept. So that's why we learned about literal equations, so that we can rearrange all of our terms and solve for y. So we're going to solve for y, and that will convert the equation into slope-intercept form. We want to make sure we keep the slope as a fraction, not a decimal, because we want to be able to see the rise and the run. So we have 3x minus 4y equals 8. In this space right here, actually, I'm just going to go to a blank spot. 3x minus 4y equals 8. I have all this space in OneNote, so let's use it. 3x minus 4y equals 8. So if I want y by itself, remember that I need to look for what's been done to y. So I have this term, 3x, that's been added, and I have this negative 4 that's been multiplied. So I need to undo both of those. The first thing I would do is subtract 3x from both sides. Once I do that, I rewrite this as negative 4y equals. Now, if I want this to be in slope-intercept form, I don't want to write 8 minus 3x. I want to put it in the order negative 3x plus 8. Remember that negative 3x plus 8 is exactly the same thing as 8 minus 3x. When we're adding and subtracting numbers, we can do it in whatever order. It doesn't matter which one comes first, they're the same. So the next thing we need to do is undo this multiplication, and we're going to divide by negative 4. And then we have 2 options like we talked about in literal equations. I could put over negative 4 like that. The problem is then I won't have 2 separate terms on the right side, and that's what I want for slope-intercept form. So instead of dividing the entire side, what we're going to do is divide each term by 4 so that we end up with 2 separate terms for my mx and my b. So on the left, we're left with just y, which is great. That's what we want. On the right, I have a negative over a negative, so I get a positive 3/4 x. So I can see my rise and run now. And then 8 over negative 4 gives us -2. So now I'm in the correct form. I can see my rise, run, and y-intercept, and I can graph it just like we did on the previous example. There's another one that has rearranging to graph here, so we're going to solve this one for y. Step 1, again, we have an addition operation here, and we have a multiplication operation here. We want to undo the addition first, so we're going to do -4x. That gives us -2y. Don't lose the negative there. Remember that this -2, once the 4x is gone, this term is still negative. It's really easy to forget and just put 2y and let this negative just kind of vanish. So don't lose track of it. We get -4x plus 6. Our other operation we need to do is to divide by -2. And again, we want to divide each individual term by -2 and not group them together as a single numerator. So we get y equals -4 over -2 makes positive 2x. 6 over -2 makes -3. So when we graph this, we have our y-intercept at 0, -3 right here. And we have a slope of 2. Remember that 2 means that my rise is 2 and my run is 1. So from my point at 0, -3, I do a rise of 2 and go up 2 spaces and write 1. So this would be my next point. You're always welcome to follow that slope pattern and add additional points. Whether you're working on paper or on a computer, the further away the points you're connecting with your ruler are, the more accurate your line's going to be. So these are really close together, so I might want to add maybe 1 or 2 more points. Now when I use my ruler, I'm not going to look at the ones in between. I'm going to be trying to aim for the first and the last point to get the most accurate I can. So I want the points to be just above, like cut through the middle of the point. So they're half on the ruler, or half above the ruler and half inside of it. I'm going to draw my nice straight line that goes all the way across the graph, turn off the ruler, and then add my arrows at the ends. And there we go. So OneNote looks like it's going to be a really nice tool for drawing straight, beautiful lines, because when we draw on paper, it's a little bit tougher. So practice. These two are just like things we just did. I'm going to go ahead and go through them, but if you feel like you've got that, you can skip. But number 2 is a little bit trickier. So feel free to skip ahead if you have this, or pause and do it on your own and then check by unpausing. So this one is in slope-intercept form, which is perfect. So we're going to plot our y-intercept at 0, 3. Our slope, just like the last problem, is 2 over 1, so we have a rise of 2 and a run of 1. If I want to add additional points, remember that we can go backwards. So instead of up and right, I can go down and left. The important thing to check is that when you're done drawing, this is a positive slope, so it needs to go uphill. Really common mistake with lines is to reverse the slope and get wrong whether it's uphill or downhill. So this one had the same slope as last time, which conveniently means my ruler is already in just the right spot. So I'm going to connect these. I don't need you on screen keyboard. Please go away. And I'm going to put my arrows. And there we go. The next one is a little weird because I don't see my y-intercept. So remember that if there's nothing there, that's the same as plus 0. And we know that 0 means my y-intercept is at 0, 0. We call this point the origin, and it's right in the middle of the graph. So I start from 0, 0, and then I follow my rise and run. This says -3 over 2 with the negative in front. We need to know that that's the same thing as -3 over 2. So my rise is -3. I go down 3 spaces. My run is 2. I go to the right 2. and here's my point. If I want to add another one the other direction, I can go up and left. Again, the important thing here is that this slope is negative, so it's downhill. Then I can bring out my ruler, take it over here and turn it a bunch. Turn. I believe on the touch screen you can use like pinch and like rotate with 2 fingers, but here I'm having to use the mouse wheel. That looks pretty good. So we'll get our pencil. Uh-oh, I didn't get the pencil. All right, get our pencil and then draw along there. And then we can put our arrows, and that one's good. So that's those two. We have some more practice. These are more of the same kind of thing. I want to look for a couple of things that may be tricky. So number 3, very straightforward. I believe you can do that one. Number 4 is not in slope-intercept form. So we want to make sure to rearrange it, just like we did with those earlier problems. We'll do y equals negative 4x minus 1. That way we don't mix up our y-intercept and our slope, since they're written out of the regular order. So we have negative 4x minus 1. We go to negative 1. Our slope is negative 4. So 1, 2, 3, 4, and 1. Or 1, 2, 3, 4, 1 the other way. And again, it goes downhill, very steeply downhill, but it has a negative slope, so it needs to be downhill. Let's see what else. Number 6 is another one where the y-intercept is 0. So we have a plus 0 here, meaning our y-intercept is on the origin. Number 7, let's see, 7 through 10. 7 through 12 are all out of order, so we need to rearrange them first. We do that just like the earlier ones by subtracting and dividing. So here I would get y equals negative x plus 4. That's after I subtract x. And then I divide both sides by 2, so I get something like that. Remember that negative x over 2 is better written as negative 1/2 x plus, and then 4 over 2 is 2. So there's always a hidden coefficient of 1 in front of that x. So it sometimes gets confusing when we don't see the 1. We forget that it's there. But this is negative 1 over 2, so my rise is negative 1. I'll be going downhill, and my run is 2. All right, these are more of the same kind of stuff, so I would say just practice those, make sure you understand them. Here's another one with a y-intercept of 0, so after we rearrange it, we'll have 3y equals negative x, but we won't write the plus 0, and then we just have y equals negative 1/3 x, and we know to start at the origin because we have a y-intercept at 0. All right, so now we get, so all of that hopefully is somewhat familiar because you have slopes. The special stuff for algebra, the one that's different and new, is horizontal and vertical, and it's what we mess up the most by far. So I want to spend some time here talking about horizontal and vertical lines. There are several different ways to remember this. This is just one of them using an acronym called HOYVUX. So in your notes, you have this acronym HOYVUX. I don't personally use that one, but if acronyms help you, then absolutely use this. So there's 2 parts. The first part talks about horizontal lines. So the H stands for horizontal. The second part talks about vertical lines. So the V is for vertical. Horizontal lines, the second thing, so the first thing we have is the type. The second is about the slope. So our horizontal lines have a slope of 0. So that O in HOYVUX is actually standing in for a 0. So we have a 0 slope. The slope for vertical lines is undefined. Remember, we can't even, the concept of slope does not apply to a vertical line because as we look at the rise over the run, we immediately move off of the line. If I try to move to the right at all along this line, the line no longer exists at all. So we have horizontal lines have zero slope, vertical lines have undefined slope. The last thing is about the equations. So horizontal lines are always y equals something, whereas vertical lines are always x equals something. So we really need to know, like automatically, that if we see y equals 7, that line looks like this. And if we see x equals -3, that line looks like this. So we should get to where we can automatically know what y equals and x equals looks like. So we have y equals 4. The reason I don't use the acronym is I try to avoid memorizing things. So I'll tell you my way of thinking about it, which is slightly different than what's presented here. But what I do is say, where does y equal 4? Because that's what this mathematical statement says. It's all of the points where y is 4. So if I look at 0, 4, 1, 2, that's right here. If I look at 2, 4, that's right here. If I look at 6, 4, 1, or 5, 4, that's here. -3, 4, right? So every point I'm making is along this horizontal line. So that's how I can remember and recognize just from the equation that I know that y equals is horizontal, because it's all of the points that have that y value. The x value isn't specified, so x can be anything, but y has to be 4. And I know I didn't use a ruler to draw that. I really should have. Let's do it. Let's be proper and use the ruler. We need the ruler to be flat, though. So let's go to 0 degrees. Right there. And then make our line. Great. So we have a horizontal line there with a slope of 0 and an equation of y equals 4. Similarly, all of the points where y is -2 would be 0, -2, 2, -2, -3, -2, and so on. So again, I end up with a horizontal line because this is all of the points where y is equal to -2. So whichever way you choose to memorize it, I think that acronym can be very helpful for first starting out and remembering, like having a mnemonic or a mechanism to remember. Hoi Vux can be useful for that. So if it helps you, absolutely use that. For vertical lines, we're going to need a 90-degree ruler here. Oh, come on, all the way around. 90, good. Okay, so x equals -3. So similarly to what I did above, I would say, where are all of the points where x is -3? So I have -3, 0, -3, 1, -3, 2, -3, -4. So it's all of these along this vertical line. So then I would take my ruler, right about there, and make my line. And arrows. X equals 1, same deal. Where are all of the points where x is 1? There's one here, 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 and so on. So I'm drawing this vertical line where all of the x values are equal to 1. Arrow. Great. So these are the ones that trip us up the most. We're going to have another way to describe these, which is maybe the most confusing part. So I'm going to go ahead and mention it here. That way, when we get to it in a week or two, whenever that is, we will have already seen it before, and it won't be the first time. Repetition is a good tool for learning. So y equals -7. We're going to learn and understand that's horizontal. But a phrasing that we'll start seeing a little bit later when we deal with parallel and perpendicular lines is something like a line parallel to the x-axis. And that really gets confusing for us because, especially if we're using this mnemonic, hoi vux, we think immediately x goes with vertical. But the axes are actually not what they seem. Because think about the x-axis. The x-axis is a horizontal line. So the x-axis is really the line y equals 0. And the y-axis is really the line the y-axis is really the line x equals 0. So when we talk about a line parallel to the x-axis, that's going to be y equals something. And if we have a line parallel to the y-axis, that's going to be x equals something. So in that case, I find it better not to think about x or y because they clash with what we've kind of memorized or learned with hoi vux. Instead, I don't think of this as x-axis. I think of line parallel to, and I say, which way does the x-axis go? The x-axis is the horizontal axis. So I'm going to replace this in my brain. When I see x-axis, I'm going to replace it with horizontal axis. That way, if I'm parallel to it, I know that my line is horizontal, and now it makes sense that we have y equals something. So instead of trying to think of it as x going with vertical, I think of it as horizontal goes with y. Same thing for the other one. The y-axis is the vertical axis. So when a problem says parallel to the y-axis or perpendicular to the y-axis, I think I have this line, and if I want to be parallel to it, I'm going to go the same way, and perpendicular, I'm going to go the other way. All right, last thing for today's notes, compare and contrast. What's the difference between y equals 2 and y equals 2x? This is a really common thing to confuse. So we need to know what these things are. So this 2 is a b value. It's a y-intercept. This 2 is an m value. So it can really help to visualize if we write this out with the missing part. So instead of just y equals 2, this is y equals 0x plus 2. And this one is y equals 2x plus 0. Then we can follow our regular pattern of how we graph it. I can see that my y-intercept is 2, so I go to 0, 2, and graph that. I have a slope of 0, so I know this is a horizontal line, like that. That was pretty good without a ruler. This one has a y-intercept of 0, so it goes through the origin, and it's what we call proportional. You've learned about that before, and we'll cover that again this year. Then we have a slope of 2. So we're going to follow our pattern by going up 2 and write 1 as many times as we want, and then use our trusty ruler to connect our points. So we're going to get the ruler. We're going to connect these guys about there and make our line. Move the ruler instead of making the line. Okay, all of these take getting used to. So we put our arrows at the end of our ruler, and these are two very different lines. This one has a slope of 2. This one has a slope of 0. Also remember that a vertical line, vertical, will never be in slope-intercept form. So we can't have y equals something for a vertical line. That's why they're weird. They don't fit slope-intercept, and they have to be always in the form of x equals something. Okay, so that's our notes for today, and we'll move on to the next one.